Alan Weir's formalist approach aims to present an evolved perspective on mathematical truth that engages more meaningfully with contemporary discussions. This approach is not only a response to criticisms of earlier interpretations, but also an invitation for readers to engage deeply with fundamental questions concerning mathematics and its foundations. The book is relevant not just for mathematicians but for anyone interested in the nature of truth, knowledge, and the role of mathematics in understanding the world. Weir opens the book by critiquing traditional mathematical realism or Platonism, which posits mathematics as an independent realm of abstract entities existing beyond human cognition or empirical experience. He contrasts this perspective with naturalized epistemology, which seeks to ground knowledge in sensory experiences and scientific inquiry. This part of the book delves into the challenge of reconciling mathematical understanding with naturalistic methodologies that rely on observable phenomena and empirical evidence. Weir argues that traditional mathematical Platonism struggles significantly when assessed through this lens, as it fails to provide satisfactory explanations for how individuals grasp abstract mathematical concepts devoid of direct experiential interaction. This section highlights the tension between methodological and ontological naturalism, illustrating how mathematics appears to transcend physicality, yet remains indispensable for scientific advancement. In this section, Weir embarks on a philosophical exploration of mathematics, advocating for a reading that embraces anti-realism while maintaining a face-value interpretation of mathematical assertions. This approach asserts the truth of mathematical theorems, such as the existence of infinite entities, without committing to their existence in an objective, mind-independent reality. The foundational premise revolves around a heterogeneous understanding of assertoric language, where various assertions do not universally function to represent reality. Instead, the author posits distinct modes of assertion, including non-representational forms that express internal attitudes or projective stances onto the world. Importantly, the proposed framework distinguishes between informational content, the literal meaning, and metaphysical content, the conditions that make utterances true or false, allowing for a nuanced discussion on correctness in assertions without necessitating empirical verification. Weir's approach to formalism, termed neoformalism, recognizes that while mathematical statements may be formulated without referencing abstract entities, their truth still hinges on proofs and refutations within a formal structure. This revised formalist position departs from earlier interpretations that viewed mathematical utterances as devoid of truth values. Neoformalism recognizes that mathematical truths depend solely on concrete tokens, rather than abstract symbols or structures, thus aligning its metaphysical content with naturalistic interpretations. By asserting that mathematical truths are contingent on concrete proofs rather than abstract entities, this position seeks to reconcile mathematics with a naturalist ontology devoid of abstract entities. This section is a critical examination of the nature of mathematical proof and its relationship to abstract entities, exploring the challenges faced by mathematical anti-realism and offering a framework for addressing these challenges. In this part, Weir explores the interplay of language, grammar, and ontological commitments within mathematics. He argues that the nature of language, particularly the concept of type, plays a crucial role in understanding mathematical constructs. The text delves into the ontology of concatenation, where various entities can be conceived as fusions, properties, relations, or processes. Weir adopts the term fusion for simplicity, recognizing that it could easily be articulated in terms of other ontological frameworks. This approach allows for a flexible interpretation of how speech or writing can be understood through linked segments. The text illustrates this notion using formal notations that define relationships between tokens based on their temporal and spatial contiguity, emphasizing that any failure in these conditions disrupts the ability to refer to definite descriptions. Weir also discusses the relationship between abstract representations, such as expression strings, ests, and grammatical correctness, emphasizing the need for semantic criteria over purely perceptual ones to differentiate linguistic tokens. Effectively, the distinction between tokens relies on semantic discriminability, the capacity for a speaker to react differently upon substitution of one token for another within specific utterances. By employing weak semantic discriminability criteria, The analysis aims to avoid circular definitions while still establishing significant connections between syntactic structures and their meanings. This section highlights the importance of language in mathematical reasoning and the need for a nuanced understanding of how mathematical expressions can be interpreted and used in various contexts. Weir concludes the book by reflecting on the broader philosophical implications of his neo-formalist approach. He critiques the notion that mathematical truths are contingent upon abstract entities or external realities, instead suggesting that mathematical truths are contingent on concrete proofs and empirical realities. This position challenges traditional Platonist views by emphasizing that mathematics is ultimately a human construct, one that transcends individual understandings, yet remains autonomous from collective human intentions. The author argues for a realist perspective towards properties alongside neo-formalist methodology, suggesting that this approach adequately addresses issues related to mathematical applicability, while avoiding pitfalls associated with other philosophical positions like heavy-duty Platonism or strict fictionalism. The book concludes with a discussion on the role of idealization in mathematics and its implications for proof theory and logical structures. Weir critiques traditional approaches that idealize mathematicians' capacities, rather than focusing on idealizing language itself, asserting that a robust idealization should emerge from theoretical constructs rather than human limitations. By systematically addressing these complexities surrounding logic, proofhood, and idealization, neo-formalism emerges not merely as an academic doctrine, but as a substantial framework capable of addressing critical issues in philosophy while preserving classical mathematical practices without ontological baggage. Weir's work advocates for further exploration into these themes to solidify neo-formalism's contributions amidst ongoing debates in the philosophy of mathematics. Alan Weir's